Sathyabama Institute of Science and Technology.
Good morning, I am Jancy Mary, Assistant Professor, Department of Biotechnology, Sathyabama Institute of Science and Technology, deemed to be University. Today we discuss the topic about monosaccharides. Monosaccharides, before that, what is meant by carbohydrates? Carbohydrates may be defined as polyhydroxyaldehyde or ketones which produce them on hydrolysis. So, functions of carbohydrates, it is a dietary source of energy. It is a storage form of energy to meet when immediate demand. It participates in the structure of cell membrane and cellular functions. It is a precursor for organic compounds. So, carbohydrates, it is stored in plants as well as in animals. In plants, it is in stored form of starch. In animals, it is stored in glycerol. Classification of carbohydrates. Carbohydrates are classified into 4 different types: monosaccharide, disaccharide, oligosaccharides and polysaccharides. Monosaccharides, it contains single sugar unit. Disaccharides, it contains 2 monosaccharide units. Oligosaccharides, it contains 3 to 10 monosaccharide units. And polysaccharide, it contains more than 10 monosaccharide units. So, first is a monosaccharide. Monosaccharide is nothing but it cannot be hydrolyzed into simple sugars. It contains single monosaccharide unit. Based on the number of carbon atom, it is classified into 4 different types: trioses, tetroses, pentoses and hexoses. Based on functional group, it is classified into 2 types: aldose and ketose. Glyceraldehyde is an example for aldose in triose, and dihydroxyacetone is an example of ketose. In tetrose, erythrose is an example of aldose and erythrolose is an example of ketose. Pentose, ribose is an example of aldose and ribulose is an example of ketose. Hexose, glucose is an example of aldose and fructose is an example of ketose. These are the structures of the triose sugars. That is, first one is a glyceraldehyde, second one is a dihydroxyacetone. Before that, it has 2 types of isomers. One is L isomer, another one is D isomer. In L form, the HO group is present in left side of the carbon atom. In D form, the HO group is present in right side of the carbon atom. Trioses in aldehyde, that is CHO, first carbon atom, it is aldehyde group. C double bond O, it is a ketose group. So, glucose is the most important carbohydrate. It is storage form of glycogen. In nucleic acid, it is of 2 types, one is ribose and deoxyribose. In milk of lactose, it is as galactose. The diseases associated with carbohydrate metabolisms are diabetes mellitus, glucosuria, glycogen storage diseases. So, biomedically, these monosaccharides are of 3 conformations. One is Fischer projection, another one is Haworth projection, next is chair conformation. Fischer projection is a straight chain, Haworth projection is a ring-like structure, chair conformation in the form of chair. Sugars exhibit in various forms. First one is a triose form, last one is a hexose form. That is, first one is a glyceraldehyde, aldehyde form, L-aldehyde and D-aldehyde. L form is, already I told, OH group is present in left side of the carbon atom. D form, OH group is present in right side of the carbon atom. Same that in glucose. So, this is 2 ring forms, ring structures of this carbohydrate metabolism. One is pyron ring, another one is furan ring. Pyron ring is a 6-membered ring, furan ring is a 5-membered ring. This is an example for glucose, glucopyranose and glucofuranose, but glucopyranose is the most common one. So, some important carbohydrates for triose, tetrose and pentoses are: trioses, glyceraldehyde 3-phosphate and dihydroxyacetone phosphate is an intermediate of glycolysis. Tetroses, erythrose 4-phosphate is an intermediate of HMP shunt pathway. So, pentoses, ribose is a structural element of nucleic acid. Ribulose, it is an intermediate of pentose phosphate pathway. Arabinose and xylose is a constituent of glycoprotein. Lyxose is present in heart muscle. Scylulose is an intermediate of uronic acid pathway. Thank you.